Exercise 7, Distribution Fitting. Imagine the commuter has provided a log of 20 previously recorded driving times. Fit a distribution with a dataset of 20 elements. Use the best fitted distribution according to A.I.C criterium. The A.I.C and B.I.C statistics are calculated from a log likelihood function. The A.I.C and B.I.C are clearly very similar. The theoretical underpinnings of both rely on Bayesian analysis, and the two different forms come from differing assumptions for the Bayesian priors. The A.I.C tends to penalize the number of parameters less than the B.I.C. There has been much discussion in the literature about which one is more appropriate, and the jury appears to still be out. The at-risk team's recommendation is to use the A.I.C unless you have reasons to do otherwise. 1. First of all, select the range of historical data to be fitted. B28:B47. 2. Choose the distribution fitting and fit command as shown. The following multi-tab window appears. The Data tab specifies the source and type of input data entered, whether it represents a continuous or discrete distribution, and whether it should be filtered in any way. The first tab is the Dataset Options tab. The Dataset options specify the source and type of the data to be fitted. The options include: Name. Specifies a name for the fitted dataset. This will be the name shown in the Fit Manager and in any risk fit functions that link a distribution function to the results from a fit. Range. Specifies a range in Excel that contains the data to be fitted. 3. Click on the second tab for the Distributions to Fit tab. The options on the Distributions to Fit tab let you select the probability distributions to include in a fit. These options can also be used to specify predefined distributions, with preset parameter values to fit. Probability distributions to be included in a fit can also be selected by entering information on the lower and upper limits of the allowable distributions. Fitting method. The fitting method options control whether 1. A group of distribution types will be fitted, or 2. A set of predefined distributions will be used. The selection for fitting method determines the other options displayed in the Distributions to Fit tab. The fitting method options include: Parameter estimation. The procedure will find the parameters for the selected distribution types that best fit your dataset. Predefined distributions. The procedure will find the best fitted distribution from a set of distributions you predefine. Parameter estimation options. When parameter estimation is selected as the fitting method, the following options are available in the Distributions to Fit tab. List of distribution types. Checking, or unchecking, a specific distribution type includes, or removes, that type from the fit to be performed. The list of distribution types that are displayed changes depending on the options selected for lower limit and upper limit. By default, some distribution types in the list are unchecked. This is because, 1. These types are specialized forms of an already checked distribution type. For example, an Erlang distribution is a gamma distribution with an integer shape parameter, and fitting them would be redundant. Or, 2. They are a distribution type not normally used in fitting, such as a student or chi-squared. You can override at-risk's choices if you like. Lower limit and upper limit options include: Fixed bound of. Specifies a lower and or upper limit. Only specific distribution types, such as triangular, have fixed lower and upper limits, so an entry for fixed bound will restrict the fit to certain types of distributions. Bounded, but unknown. Specifies that the fitted distribution has a finite lower and or upper limit, but you don't know its value. Open, extends to plus or minus infinity. Specifies that the fitted distribution can possibly extend to any possible positive, or negative, value. Unsure. Specifies that you are not sure about the possible values that could occur. At this point, we do not need to explore the third and fourth tabs of the fitting window, as they belong to advanced options not covered by beginner or intermediate usage of at-risk software. 4. Click on the Fit button. A next value distribution will be chosen among the set of available distribution functions. 5. Click on Write to Cell. We will not change any parameters here. Just keep going to Next. 6. Place the fitted distribution on cell B26 and click OK. Cell B26 should now contain the following function: equals risk text value is 60.2236, 4.6777, risk name driving time. 7. In order to view this distribution, while keeping B26 selected, click on the Define Distributions icon to view its shape and statistics. As long as a cell previously contained a distribution, at-risk will retrieve its chart for editing purposes. Otherwise, if the cell is blank, At risk will retrieve a pallet in order to eventually place a newly created distribution function. Observe how this distribution looks like when compared with the original PERT distribution generated on exercise 1. When defining on vertical delimiters on 75 and 90 minute marks, you would be able to compare how much weight has been given to different sections. While the PERT distribution assigns 23% of potential outcomes between 75 to 90 minutes, the best fitted distribution function only assigns 4% probability to this same range. Extending beyond 90 minutes, while the PERT assigns 9%, the best fitted distribution only assigns 0.2% to these highly unlikely outcomes.